Okay, so we had a request to do letrec language extensions. So I'm just going to do this on the fly. Let me do a quick screen share.
Is letrec short for something?
Yeah, it's a recursive let. It's very, very common. It's letrec is OCaml has it. A lot of functional languages have it.
The rec is for recursive and
Yeah.
oh, okay. So now I see. So let and then recursive. So let rec. Okay.
Yeah, exactly. So essentially, we want a syntax of the form let rec, and then we want an identifier. Right. So whatever you could stick as a identifier for a contract, you can put here. Right. And then you want an args list. So arg. And you can have 0 or more of them. So I'll put a star here. And then you can have, well, I'll do it this way. So equals, and then you can put whatever process you wanted here. Okay, so let me do it this way. Since I've been using that. And then you can have as many of these as you want.
So I was thinking that you will specify this as a 2 words, let and rec.
No.
As a OCaml. So this is like a special only for this construction. It's not just it's not like extension of an existing contract, or I'm thinking, for example, for peak or.
No, this is syntax. This is syntax. I mean, if you want, you can separate them. Doesn't matter. I mean, it really doesn't matter.
I'm thinking for this is not available for peak, right? Only.
This is syntax. I'm describing syntax. So this goes to parser. Does that make sense?
Okay.
Right. And then, you know, we can, with respect to the semantics, it's sort of interesting. If we're restricting only to the row calculus, then you would use the usual recursion stuff that, you know, like I specify in the paper. But what we really want is we want this to use primitive recursion, right? Since we have available to us the JVM, we want to use the JVM recursion semantics. So rather than have this go to the tuple space, this is going to use the JVM recursion semantics. So specifying this in rholang, you know, if I were to give the semantics here, this would just use the usual bang semantics, right? So as in the paper, where you know, like with the, hang on a second, I'll just bring up the paper. That's probably the easiest way to show it. Okay, here we go. There we go. There's that. Okay, PDF. There we go. Okay, so here we go. So you'd use a variant like this. So the process D, which is parametric in X, is a for comprehension. So you're waiting on X for Y, and then you send star Y down X in parallel with dropping Y. So in our screen share. All right, so D of X in rholang would be written for Y from X. And then what we're going to do is send on X star Y. And in parallel, we're going to drop X. Okay. So that's clearly recursion, right? Because if I then do, as per the paper, so let's bring the paper back up. If I send P along, if I send D of X in parallel with P along X, and put that in parallel with D of X, right? So everyone knows this calculation, right? So we're going to send D of X in parallel with P, right, to D of X. All right, you know this calculation, right? Does everybody know this? Guess not. Silence says no. Okay, so let's run it, right? So D of X is 4, right? So we're going to take this expression and substitute in this expression here. Okay, so that goes here. I won't do it there just yet. Okay, I'll put it here. Okay, so that's just the same, right? All I did was to take the definition here and substitute it in this one place. Does that make sense?
Yes.
Yes.
Okay, great. I'm gonna take all this. All right. So we'll make it clean. Suppose D of X is that, right? Then okay. And so now we can run this, right? So this reduces in a single step to on X, we're going to send, nope, I don't want you to do that. On X, we're going to send star Y, which is just this, right? In parallel with drop X. Should be drop Y. So it should be drop Y, not drop X. Okay. Okay, so what is Y? Well, it's this. Okay. Do you notice anything familiar? So this is that. Right?
Mhm.
Okay. So we know that this thing evolves to this thing. So in a single step, this will evolve to, I'm just going to replace that part of this expression with what it evolves to. So that's that, right? And then if we replace again, right? That's right. You see where this is going, right?
Can you just clarify the first step? When we send something on X,
So this
again
thing here, is going to be bound to Y. Okay. So I'm just gonna replace Y with this thing in this expression.
I see. So basically, in the next line is the body of the for. It's not the same ascending on X. This is like
yeah. I mean, this is just normal comma event, right? I'm sending this, and this is picking it up.
I mean, it looks like the sending on X stays the same, but this is different X. This is from the body of the for.
Yes. Yeah. I'm using the body of the for. That's right. Yeah.
Yes.
So does this make sense?
Yes.
Okay. Cool. All right. So let me just there we go. Make sure this is. Hello. There we go. Okay. All right. So obviously this gives you a kind of recursion, right? And you can do guarded recursion. So instead of dropping the Y, you only trigger the dropping of, you only trigger it, if you pass the guard, right? So which is a better thing to do, right? Because this goes on forever, right? If you type this into rholang, it would not terminate. Yes, obviously.
Yes.
Right. Okay. So you want to do a guarded version of this to do real recursion, or to do practical recursion, I guess. Okay. So, but we also know that you can, like if you had a recursive combinator, something that did recursion for you, like a Y combinator, that's interdefinable with this kind of replication style recursion. Yes? That makes sense?
Yes.
Okay. So, formally, we can specify this in terms of this, but in the implementation, we want to use the recursion available to us in the JVM. Does that make sense? Okay.
Yes.
Okay. So now the one thing that's tricky is that this is different than contract, which is why it's useful in addition to contract, because we can have multiple functions recursively defined. Do you see that? So an example of this syntax would be something like let rec f, and let's say f takes some variable, say u, right? And what it does is it sends on u some new name and for, well, we do it this way. I'll put it on the outside. Okay, so there's that. And then before I do the in, right, I can now define, and sorry, I want to put in parallel g of x. Okay, and now here I want to say g of x is equal to Sorry. Is equal to for y from u. Whoever's typing, maybe they could mute. Okay, and then here we want to do say f of y.
So this is like an and in Ocaml when we are combining multiple recursive things.
Yeah. Yeah.
And you're saying functions. Are you?
No, procs.
Okay.
See, I didn't say functions, I said procs.
Mm-hmm.
So there you go. So now you can do mutual recursion.
Makes sense.
So F is calling G and G is calling F.
And on the implementation level, if we how we are treating the scope for the unforgeable names? Is there something special or
no? Scope is right here. This is the scope right here.
So we have new scope for every recursive call.
That's right.
Whatever happens in this recursive call, it's like normal branching. Mm-hmm.
Yep. Normal stuff.
Mm-hmm.
There. So that's an example. This, you can see, right, that this example would be recognized by this grammar.
I see. This is the star. Mm-hmm. Oh, I see.
Okay, so that's it. That's all there's to it. No, nothing really fancy about it. But this is so when we do the implementation, we want to switch contract over to recursion, and we can add let rec to do lots and lots of mutually recursive stuff, which is very useful. Right?
So with this syntax, so I'm thinking if we want to create some kind of joins, recursive joins.
The join would be inside here, right? Right here's where your join is, and here's where your join is. This is just like with contract, right? This is basically just contract. All it is contract.
So the difference between this and the contract is the contract will occupy one cell in the RSpace, right? And but this one is totally in the JVM, right?
That's correct. That's right.
I'm not sure how do we translate this. For example, this mutually recursive, these two functions into the recursion JVM. Just a single call on JVM.
Okay. So I'll do it this way.
I mean, there's still unforgeable name creation there. So producer, like in pattern matching and all this stuff.
That's just exactly the way it's done today. Right. The only thing is instead of calling the cell in RSpace, we'll do effectively this, right? So you want to say val, or no? I guess you have to say you'll have to do something like this for if you want to do Scala. So not interested in you, auto. Thank you. So object, and then it'll be, you know, some generated name like, you know, gen name 1, 2, 3. Okay. And then inside it, we will have def f equals, and then the translation of the body here. Right. So let's say that this is a, you know, identifier 1. Right. And then arg 1, 1, blah, 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 arg 1 in 1. Okay. And then it will be the translation of, hang on. The translation of the proc1. So I'll call that proc1. Okay. Oops. Okay, and then def identifier in, let's call it m. Yeah, I can do it. I can do it in. No, I'll do m. That's it. And this would be arg m1 comma blah blah blah. Oops. Arg m and m equals proc m in, and so then and then finally you have the call, you know, say val. Well, I guess you can just do in Scala we could actually just call it, right? So whatever the proc is. So so the proc is at the bottom. Yes, yeah, that works. Okay, so now I can boom, done. So I just need to put the translation. Okay, and then I put equals here, there. So if I'm going to translate this into Scala code, right, I'm going to create an object. And then for each of the identifiers here, oh, so let me, I'm going to clean this up a little bit. So I need identifier 1. Get rid of these. And I'll put this down here. And we want this all to be like that. And then dot, dot, dot. And then this is M. And this is M, N, M. And then this is dot, dot, dot. Okay, so then I'll clean up the formatting a little bit. Okay, there you go. So the translation of this thing here, right? So from here to here, I'm translating. This is a legal, sorry. This is a legal expression that matches this grammar. Yes, you see that this matches that, right?
Mhm.
Okay, right. So to translate this, I'm going to create an object, and I just generated a fresh name for this object, right?
Mhm.
Okay, and okay, probably just to be on the safe side, I'm going to do something like and some gen name 1, 2, 3, 4. Okay, is equal to proc, and then we want gen name. Wait, what? Stop that. Oh, I see what's going on. No, do that. Get rid of that. Return, and then gen name 1, 2, 3 dot b dot gen name 1, 2, 3, 4. Okay, there we go. So I think that's all good. Okay. Yeah, that's right. Okay. So this is a legal expression. This is legal Scala code, right? From here to here is legal Scala code.
Mhm.
Okay.
Yes.
Right. So then I'm doing a define of this is equal to the meaning of this. So whatever that is, we need to go and compile that and give me back the meaning, which will be some Scala code, right? And then that will be what's available here. And we'll do that for all of these functions, right? So Scala's recursion will automatically handle the recursion here, right? And then I need to do this, right? So I'll set a val to that. And then ultimately this whole expression needs to be the meaning of that. So that's why I make the reference here. Does that make sense?
Yes, yes.
The proc 1 and proc m are the rholang expressions.
Yeah, they're rolling. Yeah, they're rolling expressions, but here, notice the brackets around them. So this bracket means give me the meaning in Scala, right? So the meaning of this whole thing in Scala is going to recursively depend upon the meaning of this in Scala. And the meaning, oh, this should be M. Yeah. So the whole thing of this expression, the meaning in Scala of the whole expression here depends on the meaning of Scala of this expression and this expression and this expression. And that's why I'm making recursive calls to the meaning of the square brackets here, here, and here. Does that make sense?
Yes.
Yeah, but how do we translate from the rholang to the meaning? So we have the rholang code.
I just gave you that, right? This is a function that is recursively defined, right? So this is translating a piece of the rholang, and then you will go through each of the cases and translate a piece of the rholang, right? And that's essentially what the code in the code base today does. So I can go and spec this all out, but it's obvious how it works, right? So for each, so to make it work, you have to have, your RSpace, which I'll call R, right?
But in Scala, we still will be calling all the rholang machinery. Like we will be using reducer to execute the rholang code.
Yeah, exactly.
In the proc.
Yeah.
But it's just that we can not serialize because we don't need event log. So this is
You don't have to do the event log for this one, or you don't have to do the way contract does events.
We are scaling RSpace with produce and consume. We are not calling produce and consume.
From the
reducer.
This is like contract without produce and consume for the contract identifier.
This definition of let rec now looks similar what previously you had defined as def in the in the local post, right?
Yeah.
Now this makes sense for me because this def was replication, right?
Yes.
That you had previously.
Yeah.
Oh yeah.
So it should be clear now. Yeah.
Yes.
Okay.
Cool.
Great. So this is all bog standard, right? If you've written, compilers and interpreters for little languages, then there's not a lot of, fancy stuff going on here. Yeah. There's a little detail that you'll have to worry about, but you'll see it when you come to it. And then if you get stuck, I can explain it to you. But this is the bulk of the thing.
I'm also thinking we need to take into account when we're translating this to Scala, we should take into account Stack Overflow with recursion.
Yeah.
So that we have like a tab rec and
yeah, absolutely. Yeah, you got to do that, right? Yeah. But at the end of the day, programmers can write stuff which will generate Stack Overflow, and that's their fault, right? There's nothing we can do to prevent that. Like if they write it, we got to say, okay, that's what you wanted to do. Like, you know what you're doing, right? We can't like rewrite their code to make it safe, right?
Yes. I mean, we can ensure that recursion is a part of the heap and not on the stack. In that case, you have memory and that's it.
Yeah, exactly. That's right. So that's it. I mean, that's all there is to it. So it's not a big, deep thing, right? I mean, there's a lot of deep stuff about recursion, but in terms of, standard language definitions, there isn't. So I can print this out and send it around. Let me just make this a little bigger.
I think it'll be good if we update the rholang 1.1 syntax document that was there before with this, if this is final enough for that.
This is somewhat informal. I can make it a slightly more formal. Okay, just leave that, and then I guess I'm going to say something like, example, and then we want to say, sorry, I'll just clean this up a little bit, and then I'll send it around. Is this? There we go. That's what I thought. There. Is that right? Yeah, that's correct. Okay, and then so we'll bring this down to about here, and then say.
So when we are using the identifier of let rec, it feels like a function call, right?
Yes.
Yeah, so from my understanding, like this identifiers works like a temporary function call within the scope of this code block, right? So
no. This is an assignment, right? It's like a generalized assignment. What we're saying is, or it's really a definition, right?
Right.
We're saying that this is defined to be this thing, whatever's over here. So whenever you see one of these, you replace it with one of these. It's not a
Like
call.
a very simple macro in a sense.
Yeah.
Yeah. It's more like a more like a macro.
Mm.
It's a let rec expression. It's not really a macro. No, the macros do something different, right? They do something different in terms of evaluation. So yeah, be careful with that interpretation. Right. So here is where you should think about it, right? Or here's the best, right? We're saying F has this, F is defined to be this. I mean, and it's just like in Scala, right? You know, when we say this is a def, right? Def. These are defs. These things are defs. Right? So if you need to think about it like this, just like in Scala. Or, you know, Ruby or Python or whatever. It's all the same. Okay. And then we want to say, I'll just add one more little comment here, and then I can send it out. But we don't want to use replication for efficiency. Instead, we want to use the recursion available natively from the JVM. No. There.
I'm thinking, can I use this even if I don't have recursion? If I just want to.
Yes, you can. Absolutely. Yeah. Like, yes, right. Yes.
Because now I have like some kind of version of function, and yeah.
Yeah, I mean, it's not really functions, but whatever. It's not really functions because these aren't expressions, right? These are more like statements than expressions. In other words, these don't return values, right? And they might return values, but it's a little different in the row world than it is in functional world.
Oh, I was thinking that I'm returning a process in that sense.
No. What you'll do is you'll evaluate this process. It doesn't, right? So this process could be, you know, send on X, receive on X. There's no value there. It's a process expression. So that will reduce. If it turns out that the reduction goes to one of the ground values, right, then it does have a value. But in many cases, it doesn't have a value.
I was thinking more into in a sense of, for example, in your example, when we are saying f of y, I'm thinking in a way that I'm calling f, and I will evaluate whatever f returns me, and this is my this process that I get is.
No, that's not the way to think about it, right? The way to think about it is we're going to take this expression, just like it's like a contract, right? So think of this as like, these are like local contract definitions. F is a contract, G is a contract. So I'm running the contract, not calling it. So I'm going to run the contract with Y in place of U, right? So this expression here will result in new X, let's call this X prime, or let's call this V so that it's not confusing. We don't It isn't confusing, but it doesn't matter. Okay, so I have a new V. So this is going to result in this expression being evaluated. So that's going to be send on V, this fresh X, in parallel with G of V. And G of V is going to be listen on V for Y, and then after you've got it, call or run F of Y. And so this will loop forever.
Yeah, makes sense. Makes sense. I mean, I see it as a f of y is like I'm getting the process that I can evaluate.
Yes. Yes.
Mm.
Okay. All right. So. Yes. Yeah, that's it. That's the whole. So
would you allow for let to be defined in this way, even if you're not considering rec, to have this kind of assignment with arguments?
That's the whole point of rholang 1.1 is that let becomes val expressions in Scala.
But without arguments. With arguments, this becomes even more interesting.
No. Hang on a second. Let me cancel this. If you look at the rholang 1.1, you'll see that the whole point of let is that instead of doing the put it into a cell, take it back out of a cell, you're going to use the val stuff, right? The let is going to correspond to an object where you have a bunch of vals which are equal to the vals there, whatever the evaluations there, right? But you don't want arguments apart from the extended for comprehension stuff has arguments, but the let stuff, you don't want arguments unless it's a function. And that's what this does. So just you can use let rec. This thing doesn't have to be recursive.
I see. Yeah, this makes sense.
Yeah. But this is for functions. That's really what it's for. Cool. All right. Yeah. So if you know OCaml, then you kind of get so Scala comes directly from OCaml, right? So rholang syntax is heavily influenced by the Scala syntax, and Scala comes directly from OCaml. So that's what's going on here. Yeah. Coolio.
I have more experience with F#, but F# is also
F# also comes directly from OCaml.
Yeah.
All right. Thank you, everyone. I appreciate your time and attention. Great questions.
Thanks.